about imaginary numbers. Now let us see about a complex number. For that, now I am going to solve this quadratic equation by formula method. X square minus 4x plus 8 equal to 0 means we can solve by any one of the methods. Now I am going to use this formula method. X equal to minus b plus or minus root of b square minus 4ac by 2a. Now we can substitute these values one by one. Here a equal to 1, b equal to minus 4, c equal to 8. Now minus b means minus of minus 4 becomes plus 4, then plus or minus root of b square means minus 4 the whole square minus 4 into 1 into 8 you can say divided by 2 into 1. Now which is equal to 4 plus or minus root of, this is 16 minus 32 gives minus 16 by 2 you can say. Now see here, this is root of minus 16. Here you cannot get the real roots. Here you can get only imaginary roots. For that, already we have seen in the last class. 4 plus or minus root of this minus 16 can be written as 16i square, where i square is equal to minus 1. This 16 can be written as 16 into minus 1. That minus 1 can be replaced as I square by 2 you can write. Now which is equal to, this is 4 plus or minus. Now these are positive numbers. If you can take the square root for these things, you can write 4i. Square root of 16 is 4. I square root is I by 2 you can write. Now you can say x is equal to this 4 by 2 gives 2, then plus or minus 2i we can say. Now this value 2 plus or minus 2i, this is called a complex number. That is, now we know very well this is a real number. This is a real number and this is an imaginary number. Imaginary number. Now what about this I? This I is called imaginary unit. This I is called imaginary unit. Now here, see, look at this one. This 2 is a real number. This 2 is also a real number. Since it is a coefficient of this imaginary unit, this entire thing is called imaginary number. Now here the combination of a real number and an imaginary number may be called as a complex number. That is, any number is of the form x plus iy or x plus yi. Any number is of the form, that is a combination of a real number and an imaginary number, may be called as a complex number. Therefore this number 2 plus or minus 2i means 2 plus 2i and 2 minus 2i. These two things are called complex numbers. Now see the definition of the complex number. That is what rectangular form. That is a rectangular form of a complex number. Rectangular form of a complex number. Any number of the form x plus iy or x plus yi is called the rectangular form of a complex number. Now this rectangle for the complex number is denoted by the letter z. Z is equal to x plus iy, or you can write z is equal to x plus yi. Now we used to write any one of these two forms. Now you can say this x is called real part. X is called real part and this y is called imaginary part. Imaginary part we can say. Now z equal to x plus iy means that the real part of z is denoted by real part of z. Re of z is called real part of z is nothing but x. Now the imaginary part of z is denoted by Im of z is equal to y you can say. Now what is this I? I is called imaginary unit. Imaginary unit with the property that I square is equal to minus 1. This you should not forget. I square is always equal to minus 1. Now this is the definition of a complex number. Now represent a complex number in different forms. Let us consider the complex number z is equal to a plus ib. This a plus ib is a complex number. This a is called the real part and b is called imaginary part, and this I is called the imaginary unit. Now this can be represented as an ordered pair a comma b. That is, we are going to consider this real part as x ordinate and the imaginary part as y ordinate. Now let us see how to plot this point in the graph. We used to take this is x-axis and this is y-axis. Now along this x-axis we can take a real part, and along the y-axis we can call it we can plot this imaginary part. Therefore x-axis is called the real axis and this y-axis may be called as either imaginary number axis or imaginary axis. Now we want to plot this point a comma b, means just you can plot this as z is nothing but this coordinates a comma b. Now this is the point that we are representing as a point which coordinates a comma b. Now this is a complex number. Now this whenever you plot this point in this plane x o y plane, this plane can be called as organed plane. This plane can be called as organed plane, or you can say this is a complex plane, because in this plane we are going to plot only the complex numbers. Hence this plane is called either organed plane. This is a mathematician who introduced to plot the complex numbers in this plane. Therefore by his name we can call it as organed plane, or this can be called as a complex plane. Organed plane or complex plane. Now this we are represented as a point. Then how to represent this complex number as a position vector? Now see here, for that you consider this is x-axis, this is y-axis, and this point z you are going to consider whose coordinates are a comma b. Now this if you draw this line from the origin and you assign the direction, now it becomes the position vector of the point z. That is oz can be called as position vector of the point z. Now this is nothing but a plus ib. This is nothing but a oz. That is oz vector is equal to a plus ib, you can say. This is the position vector we are going to represent. The same thing can be represented as a vector, as any vector. This is origin, this is x-axis, this is y-axis. Then if you draw like this, if the initial point is origin, it can be called as position vector. If initial point is somewhere in the origin plane, now this is initial point and this is terminal point, it means now this vector can be called as any vector. This is nothing but a plus ib, or you can say this is vector z, you can say. Okay, likewise we can represent any complex number in this xy plane called organ plane or complex plane. Now if you plot as a point, this is simply what a complex number. Now here if you plot like this, you are drawing a vector from the origin. It is called position vector of this complex number z. Now if the initial point is anywhere except the origin, that is called simply a vector. Therefore this can be represented as a point or as a position vector or as any vector in the origin plane. Okay, yes. Now, the algebraic operations on the complex numbers. The first one, let us see about the equality of two complex numbers. Equality of two complex numbers. Let us assume the two complex numbers z1 is equal to x1 plus iy1, and another number is z2 is equal to x2 plus iy2. Now these two complex numbers are said to be equal. z1 is equal to z2 if and only if their corresponding real parts and imaginary parts are equal. That is z1 equal to z2 if and only if the real part of this one is x1 must be equal to the real part of the complex number z2, x2, and the imaginary part of Z1 is Y1 should be equal to imaginary part of the complex number Z2 Y2. Therefore, these two complex numbers Z1 and Z2 are said to be equal if and only if their corresponding real parts are equal and also their corresponding imaginary parts are equal. Then we can say, for example, suppose you take alpha plus I beta is equal to 2 plus 3i means now these two components are equal means here unknown alpha. This alpha will be equal to 2. Therefore, alpha equal to 2. And what is this beta? Beta is equal to 3 you can say. Likewise, you can equate. And now you want to equate two complex numbers. We have to equate only their corresponding real parts and imaginary parts. Multiplication by a scalar. By a scalar. That is, if you consider the complex number z is equal to x plus iy, and let's assume this k is a scalar which is not equal to 0, that is k is a non-zero scalar. Then if you want to multiply this kz means kz, you want to multiply z by the non-zero scalar k means you can write k into x plus iy. That is, you can multiply these two real and imaginary parts separately by this non-zero scalar, that is kx plus I into ky we can see. Now likewise we can find out the multiplication of a scalar of the complex number by a non-zero scalar. For example, suppose you want to take z is equal to 2 plus 3i. Want to find that is 3z means you have to multiply each and every part of z by 3, that is 3 2s are 6 plus 3 3s are 9. Likewise we can find out. Now this is called as multiplication of a complex number by a scalar. Okay, next we will see about a negative of a complex number. Now what is a negative of a complex number? Third one. Of a complex number. Now what is negative? You know very well what is negative of 5 means minus 5. So what is negative of minus 7 means plus 7. Just we have to change the sign. Now if you consider the complex number z is equal to x plus iy, then the negative of z is nothing but minus z. Minus z, how do you apply? If you multiply z by minus 1, you will get minus z. Therefore, here also, if you multiply this x by minus 1, like this scalar, we can get minus x. Then plus I is there. You have to multiply this imaginary part by this minus 1, we will be minus y. Now, this is called negative of z. That is minus z is equal to minus x minus iy. Therefore, whenever you want to find the negative of a complex number, just you change the sign of both real and imaginary part. For example, if z is equal to 2 plus 3i, what is minus z? Minus z is equal to minus 2 minus 3i. Suppose if z is equal to minus 2 plus 3i means then what is minus z? Minus z will be, just you have to change the sign I told, that is this minus 2 becomes plus 2, then plus 3 becomes minus 3, is minus 3i. Likewise, you have to change the sign of both real and imaginary part to get the negative of a complex number. Then after that, let us see how to find addition and subtraction and multiplication of a complex number. Now let us see here. You can consider two complex numbers z1 is equal to x1 plus iy1 and the another complex number z2 is equal to x2 plus iy2. Now we want to represent this as an ordered term, means we can say z1 is equal to x comma y. Now z2 can be written as x2 comma y2. Now, we want to find the sum of these two complex numbers z1 and z2 is equal to, z1 is equal to x1 plus iy1, then plus, what is z2? x2 plus iy2. Now I have to add this. How do you add this one? Already we know very well how to add the two matrices of same order by adding their corresponding elements. Likewise, whenever you want to add two complex numbers, you have to add only their corresponding parts. That is, you have to add real part with real part and imaginary part with the imaginary part. Likewise, here you consider this is a real part x1, this is another real part. Therefore, these two can be added together to get the real part of the sum of these two. Then plus iy1 plus iy2. I can be taken commonly outside, then you can get y1 plus y2. Now this is nothing but sum of two complex numbers. How you are adding? By adding the corresponding real parts, then plus I into sum of the corresponding imaginary part. Likewise, you can add. Now I want to represent this as a point, means you can write x1 plus x2 comma yn plus y2. Now this how to represent in the organ plane. See here. Now you can take z1 here. This is z1. Then you can take here, this is z2. The coordinates of z1 will be x1 comma y1. The coordinate of z2 will be x2 comma y2. Now I want to find the sum of these two. Z1 plus z2 means we are going to use the concept of vector. Now we can by considering this is one vertex, this is another vertex. By considering these two are two adjacent sides, we are going to form a parallelogram. We form a parallelogram. Now this is z1, this is z2. Now this vertex is O. Now this vertex can be called as sum of z1 and z2. This is z1 plus z2. Now you can take the coordinates x1 plus y1 comma x2 plus y2. Now this is nothing but the sum of these two complexes. Here we are adding the parallelogram law of addition. That is, if you consider this diagonal from the origin, this is nothing but z1 plus z. This vertex is z1 and z2 can be considered the vertex of the diagonal drawn from the origin. Likewise, you can consider. Now this is the meaning of sum of the two complex numbers. Next we will see about subtraction. See the addition of complex numbers. For that, you can consider two complex numbers. Z1 is equal to x1 plus iy1, and the another complex number z2 is equal to x2 plus iy2. Now we want to represent this as an ordered pair, means we can say z1 is equal to x comma y. Now z2 can be written as x2 comma y2. Now we want to find the sum of these two complex numbers z1 and z2 is equal to z1 is equal to x1 plus iy1, then plus what is z2? x2 plus iy2. Now I have to add this. How do you add this one? Already we know very well how to add the two matrices of same order by adding their corresponding elements. Likewise, whenever you want to add two complex numbers, you have to add only their corresponding parts. That is, you have to add real part with real part and imaginary part with the imaginary part. Likewise, here you consider this is a real part x1, this is another real part. Therefore, these two can be added together to get the real part of the sum of these two. Then plus iy1 plus iy2. I can be taken commonly outside, then you can get y1 plus y2. Now this is nothing but sum of two complex numbers. How we are adding? By adding the corresponding real parts, then plus I into sum of the corresponding imaginary part. Likewise, you can add. Now I want to represent this as a point, means you can write x1 plus x2 comma yn plus y2. Now this how to represent in the organ plane. See here. can take Z1 here. This is Z1. Then you can take here, this is Z2. The coordinates of Z1 will be x1 comma y1. The coordinate of Z2 will be x2 comma y2. Now I want to find the sum of these two. Z1 plus Z2 means we are going to use the concept of vector. Now we can by considering this is one vertex, this is another vertex. By considering these two are two adjacent sides, we are going to form a parallelogram. We form a parallelogram. Now this is Z1, this is Z2. Now this vertex is O. Now this vertex can be called as sum of Z1 and Z2. This is Z1 plus Z2. Now you can take the coordinates x1 plus y1 comma x2 plus y2. Now this is nothing but the sum of these two complexes. Here we are adding the parallelogram law of addition. That is, if you consider this diagonal from the origin, this is nothing but Z1 plus Z. This vertex Z1 plus Z2. If you consider this a vector, subtraction of one complex number with the other complex number. That also very similar to this one. Instead of adding, we are going to subtract. How do you subtract one matrix from the other matrix? By subtracting the corresponding elements or by adding the matrix with its additive inverse. Likewise here, we have two complex numbers. How do you subtract one from the other? Means you have to subtract their corresponding parts. That is, instead of writing Z1 see, Z1 minus Z2 means Z1 equal to x1 plus iy1, Z2 equal to x2 plus iy2. You have to subtract. Here what you have to do, you have to subtract the corresponding parts. Real part with real part, imaginary part with imaginary. That is, you can write x1 minus x2, then plus I into y1 minus y2. This is iy1 minus iy2. I have taken I common is getting y1 minus y2. Now with the right as a coordinate, you can write x1 minus x2 comma y1 minus y2. Likewise, we can subtract. Then how do you subtract one complex number from another complex number? Means just you have to subtract real part from the real part and imaginary part from the imaginary part. Likewise, you can easily find. Now let's see how to find its graphical representation. See here, this is Z1, this is Z2. Now this is the diagonal drawn from the origin, and the other end of the diagonal will be Z1 plus Z2. That is sum of these two complex numbers. Based on this one, we are going to see about Z1 minus Z2. This Z1 minus Z2 is nothing but Z1 minus Z2 is nothing but sum of Z1 and minus Z2. Sum of Z1 and minus Z2. Now, if consider this as a vector, this is vector 1. Suppose you draw in this opposite direction, then this will be minus Z2. This will be minus Z2. If you draw the vector in the just opposite direction, it becomes a negative of a vector, we can say. Now, see, consider, if you consider this is one adjacent side, this is another adjacent side of a parallelogram, then you construct a parallelogram. See, now this O, Z1, Z2. Now you can take this another vertex. This is a parallelogram. In this parallelogram, now this is the diagonal drawn from the origin. Then what is this diagonal? Nothing but sum of these two adjacent sides. This is Z1, this is minus Z2. What is the sum of Z1 and minus Z2? Nothing but Z1 minus Z2. Therefore, this will be Z1 minus Z2. And whose coordinates are x1 minus x2, comma yn minus y2. Likewise, you can consider the subtraction of one complex number from the another complex number. This is the way of representing the subtraction of a complex number. Okay, now let us see Now we have seen addition, subtraction. Next we will see about multiplication of a complex number. Complex numbers, for that I have considered z1 and z2. The z1 into z2 is equal to x1 plus iy1 into x2 plus iy2. Now, how we have added two complex numbers by adding corresponding parts. Similarly, how did you subtract one complex number from the other complex number? Means you have to subtract from their corresponding real parts and corresponding imaginary parts. But here not like that. Ordinary multiplication. Just see here. First you can take x1 and you multiply with x2 and iy2. That is x1 into x2, x1 into x2, then plus I into x1 into y2. After that, you come here, iy1, you consider this iy1, multiply with these two things, that is plus I, y1 into x2, you can write x2 into y1, then I into I square, then y1 into y2, y1 into iy2, I into I square, y1 into y2 I have written. Now whenever you have I square, that can be replaced as minus 1. Therefore you can write this as x1 x2 plus I x1 y2, then plus I x2 y1, then this I square value is minus 1, therefore you can write minus y1 y2. Now here also we have many terms. We try to simplify. Means we have to club real parts together and the imaginary parts together to bring into the standard rectangular form. Therefore this is a real part and this also a real part. Therefore you can write x1 x2 then minus y1 y2, it is a real part, plus here these two are imaginary parts. Here we can take I commonly outside, then you will be getting x1 y2 plus x2 y1. Likewise we can write, now this is the product of two complex numbers, x1 x2 minus y1 y2 plus I into x1 y2 plus x2 y1. Now just you should not you need not mug up these things. Just as usual you multiply the complex numbers. Whenever you have the power of I more than 1, that is to be replaced. That is, you have I, you can leave it. I square means that is to be replaced. I cube means that also is to be replaced. Therefore we can replace this I square as minus 1, then we will be getting. Now here I am going to simplify this term. That is x1, x2, y1, y2 are the real parts, therefore you can combine together. Then these two are imaginary parts, you take I outside, then you write this x1, y2 and x2, y1 as the imaginary part. Now this is the multiplication of the two complex number. This if you want to write as an order, that you can write x1, x2 minus y1, y2, comma x1, y2 plus x2 y1. Like this you can write. Here there is nothing but x1 and x2 both the real part. This is both imaginary part. Therefore, whenever you want to multiply z by I, that is imaginary unit. Let us consider is z is equal to x plus iy. Now we are going to multiply the z by the imaginary unit I, that is iz. What is iz? I into x plus iy. Just to remove the bracket, I into x becomes ix, then plus I into I square y, now which is equal to ix minus y. Now this can be written as minus y plus ix. Now this is iz. Now z is equal to x plus iy. This how you represent as a point, as an ordered pair x comma y. Now iz becomes, you can write as minus y comma x. For example, if it is 2 comma 3 means this will be minus 3 comma 2. That's all. Okay. Now how do you plot these 2 points in the organ plane? See here, if you consider the organ plane, this is x axis, this is y axis. Now this x plus iy, you can take this is z. This is z, whose coordinates are x comma y. Now if you multiply this z by I, you will be getting this minus y comma x. Minus y comma x means it will be here. z by I, it becomes iz. The coordinates of iz will be minus y comma x. Therefore, whenever you multiply a complex number by the imaginary I, this is nothing but rotation of the z by 90 degree or pi by 2 radians in anti-clockwise direction, that is a counterclockwise direction, through this about this origin. The multiplication of a complex number is the rotation of z by 90 degree in counterclockwise direction about the origin O. Therefore, again if you multiply this iz by I, then again there is a rotation by 90 degree. Now this will be I square z. If you multiply iz by I, it becomes I square z. Again this is again rotation of what 90 degree. Then again if you multiply this iz, I square z by I, it becomes I cube z. This I cube z is nothing but this one. This is I cube z. Now this is again rotation of 90 degree. Therefore this is also 90 degree. Therefore multiplication of a constant z by the imaginary I once it is the rotation of this z from one position to another position by an angle 90 degree through the origin. Every time it will be rotating like this. Now this is what multiplication of a complex number z by I. This also you should remember. Now after that we have seen only equality of two complex numbers and addition of complex number, negative of a complex number, then subtraction of a complex number from the other complex number, then multiplication. There is another operation called division, z1 by z2. z1 by z2 we did not see now, we will see later in the next exercise. Okay, now after that we will see the exercise problems in the next class. Till then you try to revise these things. Thank you children.